as much logic as you can into SQL instead of the programming language. And the reason for this is not necessarily that SQL is better at it or anything, but just because the fundamental reason is you're trying to reduce the number of queries. So instead of like doing a select, checking if anything exists, then doing an insert, you can just do an insert ignore. And the other example we saw was we just added some condition to our where clause so that we can say, well, is this new thing going to be greater than the existing thing? Then update it, otherwise don't. And the reason is just that the network latency is vastly more expensive than any kind of computations that might be going on. So imagine if you're just writing a program, not database related, but imagine if every time you had to call a function, you had to go to some server to call that function. That's basically what's going on here. However, so we talked a bunch about that last time. However, I've said it many times and I'll say it again. The number one rule of optimizing is don't, so why are we spending all this time optimizing? Well, you have to decide whether it's worth optimizing it or not. And don't optimize if it's going to hurt your design. So you just kind of have to pay attention, like, is this actually going to be a bottleneck? And is it going to make my code way uglier to do it the fast way? The examples we saw on Monday were all both faster and better design. So you shouldn't be using exceptions for non-exceptional things, like trying to insert a non-duplicate when you expect there to be duplicates. But there are often cases where it's kind of a trade-off. So let's look at an example that's actually come up a bit. So you're working on making your tables right now for the LMS. And we've got this question a lot. Should it be an int for the UID, or should it be a char, a string? And you could do either. So the difference is, well, there are pros and cons to each. So let's look at if we make it an int. Then creating a new user account. Whenever you create a new user account, you have to pick a unique UID. So here's the LMS. Let's go over to the register page. And so it lets me, pick a role, pick a major or a department, a name, a date of birth, password, and everything. But there's obviously nothing in here for me to pick my own UID. That's determined by the system for you. I should really change this so the default is not 2,000 years ago. Anyway, so your web server, or somewhere in your code, you're going to have to find a UID that has not been used yet. If you make it an int in your tables, then all you have to do is just like insert into users and let it auto-increment. The other thing is int makes a better primary key than a string, just because it's fewer bytes. Comparisons on int are faster, but that's an optimization that may be premature. The bad thing about this is the web server UIDs do actually have a U in them, which is not compatible with int. And the web server is going to expect U's to be in UIDs. So it's going to provide them in the URLs, and your web server controllers are expected to return UIDs with U's in them. So you would have to just in C#, or you could do some of this maybe with some fancy SQL magic, but you would have to strip off U's and add U's. And what if there's a really low UID, like 25? As an int, that's just 25. And if you get that out of the database, it's not going to put a bunch of zeros in front of it. But your code will have to figure out how many zeros do I need to prepend and then a U in order to make it a proper UID. Which is all not a big deal. You can easily write C# code to do that. So let's look at if we make it a char. No messy conversions from URLs, no messy conversion when I return something back to the web server. The bad thing is, so here's kind of what creating a new user looks like. So let's just kind of step through this. First, I can select all UIDs from all users' tables. This is kind of showing users are all in one table. You might have put them in multiple tables, but you can do order by UID, and even if they're strings, it will order them correctly as though they were ints. So you can use order by UID, descending, limit 1 to get the highest UID you've returned yet. Then strip off the U, convert it to an int, +1, put the U back on, convert it back to a string, and then insert into the user's table. So all this stuff in the middle, like stripping off the U, stuff like that, simple little C# code is not a big deal, but here's the bigger issue is that now creating a new user is 2 queries instead of 1. Okay, yep.
Would this create a possible race condition where one creation will succeed while the other will fail because it's trying to insert a duplicate UID?
So is this potentially a race condition? Yes. What if 2 people are trying to create a new account at the same time? So the way to fix this is either in your web server code, you could put a software lock around this, or in the database, you can wrap this into something called a transaction, which is kind of the same idea. It's like a lock. So how big of a deal is this performance-wise? 2 queries versus 1. But how often do you create an account? So even take an example like Facebook. Probably only has like maybe a few hundred accounts created per day or something like that. Maybe more, but it's not a ton. So an extra 100 milliseconds when you're creating your account, not a big deal. And so this really messy code only appears one place in your web server in account creation. And then the rest of your code that deals with UIDs is all straightforward. No conversion to strip off U's and add them and things like that. So you just kind of have to think about it. Pick which one you are more comfortable with. I'm going to recommend making them string instead of int, just because fewer places you have to think about it. Okay. So any questions or comments on this? All right. So for something like a web server, especially an LMS, where the queries that it's going to run are basically driven by user input. And the user input in this case is like clicking on fields with a mouse, slowly typing in things, and then finally, like maybe once a minute or something, you're clicking a button. So very few queries like per second actually generated in the case of a web server. In the case of one of the examples we did last time was, say you have a giant text file of grade corrections or score corrections, and you have to basically refactor an entire database. That's where the performance will start to matter. And homework 5 is going to be like that. You're going to write a tool that will upload like vast quantities of data to a database from a file. And the bottleneck there is going to be number of queries ran. So let's just kind of show you what you're doing for homework 5. So it's a little like native Windows application with just a Windows GUI. This one is really ugly because I kind of made some of the things. I made the font large enough so you can see it. Yours isn't really going to look like this, and I did it very quickly and kind of rearranged things very haphazardly just to make them fit. I didn't make the font bigger on like some of them. So pay no attention to how ugly it looks. But basically this is just a little application for interacting with the chess database. So it allows you to upload new games from a file given a certain format. And then it lets you do queries. So I could do something like, find all games where the white player was Magnus Carlsen. Okay. So let me look at the database we're dealing with here. I'm using chess2 just because we're going to be deleting and adding things. I don't want to mess with the chess database that you've used. It's the exact same format though, same schemas. Right now, there's nothing in it. So games is empty, events is empty, players is empty. So what we can do is, so I'll type in my credentials. So those two tiny things you can't see up there are the username and password. And then there's this upload PGN button, which will let you go and select a file. So let me show you the kind of file we're dealing with. It's just a plain text file in PGN format, which is like a standard chess format. And basically, it just has a bunch of tagged data, event name, site, date, white player, black player result, all this stuff. And then followed by a blank line, and then followed by the list of moves. And it's a rigid format. You can rely on the tags being here, so you can easily parse this text. And then it's just after the moves, another blank line, and then another game. And there are like hundreds of them in here. So just lots and lots of data that we want to upload to our database. And so let's take a look at this. Here's one game. All of this is one game. It took place at the event Gibraltar Masters 2018. Here's another one at that same event. Different players, different game. If we go down a bit, we'll eventually get to some other event. So potentially duplicate events, potentially duplicate player names, but everything in here is a unique game. Okay, so let's upload that one. So remember, right now we have 0 games in the database, and I'm going to go pick that moderate.pgn file, and then it starts uploading them to the database. This is where number of queries that it requires for you to do something matters. The only bottleneck here is network latency. In fact, I just tested this earlier from my office, and it went about twice as fast as this because my connection was a little better. So we'll just kind of sit here and wait for it for a minute. But so I provide this whole interface for you. You provide the code that takes a file path, parses all of that text data we just saw, and runs the appropriate insert commands. And then you just run a little function to tell that progress bar to move. So you don't even really have to do much there. Okay, so now I'm not going to select star, I'm going to select count. And so a bunch of games in there. 809 games, but only 37 events. It comes before white player or whatever. You can't assume that all of the tags you need will be there. And you can't assume that all of the tags will be before a blank line, before the moves. So, a lot easier. Because that's not the point, A very small portion of this assignment is like C# debugging, is the things like search for all games where Magnus Carlsen was white. So I click the go button, and there are 3 games in there. And it just kind of dumps them in a certain format, and then, so you'll return that, and then the UI will display it in here. Or you could say, give me all games where white was Magnus Carlsen and the winner was black. And There aren't any because Magnus Carlsen never loses. So that's kind of the basic idea. So another thing I want to show you is, let me go back up. I'm going to upload another PGN. This time I'm just going to select this small PGN file. It's very small, so it's already. You can't rely on C# logic to uniquify things. You can't assume that all of this information will be in one file. You have to actually go to the database because whatever file you're uploading right now might have the same event or players as some that came from some other file and are already in the database. So basically your logic comes from SQL mostly, not from C#. Okay? Yep.
What would happen if you had two identical games from different files?
So if you had two identical games from two different files, unfortunately our system has no way of preventing that. And in reality, in fact, that's something that could happen. You could have two players, the same players, playing at the same event as white and black, and they could play the exact same sequence of moves. And our system just doesn't have enough information to uniquely identify those two things as being separate. Well, actually, no, they will be separate. In reality, they're probably not. It's probably an error in the data, and the same game was in there twice, but ours will show it as two games. Not a big deal, though. Okay, we can do things like, there's a date picker here. So I'll go way back to like early 2018. So January 1st is the start date. We'll do like February 1st is the end date. Take off this filter. And so there were that many games played between those two dates. So let's just kind of look at your part of this here. Here's Visual Studio. I will provide you a starting point. I'll provide you a solution with a bunch of code in it. There's the UI itself, which you won't really do anything with. There's the code that runs the UI you're dealing with and aren't dealing with. So here's button one click. That's the upload PGN button. It basically runs the file dialog, lets you pick a file, and then runs something in the background. The thing it will run is this method, upload games to database. So you will implement that method. It provides you the path to the PGN file, and that's it. Okay, and then the other thing, let's just kind of go down a little more. Here's the other button. This is for the go on the, filter some games. It runs this method, perform query. That's the other method you'll implement. So really you're only implementing two methods here. It does all of the work for passing in all of the filter data, like who's white, who's black, who's the winner. It pulls all of that out of the UI and just passes it in as parameters. So let's look at the code. This is actually my solution. I'm showing you a little bit of it, but it's not really anything special. Here's upload games to database here. Given that PGN file name, go load that, turn it into some C# objects that has all the necessary fields you need. So mine just returns a list of chess game, which is the class I made. Okay, and then essentially, so create the SQL connection, open it, for each chess game, run an insert command. And then, so this is for the events. It'll also run commands for inserting the players and the games and if necessary. Okay. There's more down there I won't show you. This is kind of just the very most simple part of it. Let me scroll. Let me go down to perform query. So here's the other method you'll write. You're provided a bunch of parameters, which basically makes up the query filters. And then you'll take those parameters and just programmatically kind of create an SQL command. So instead of knowing the command you want to run ahead of time, you have a bunch of variables and you write C# code to dynamically create some kind of SQL select statement. Okay. Now let me go back to the chess browser. I'm going to upload another PGN file. I'm going to upload this one called mystery.pgn. It's smallish. It's got like 10 games in it. So it'll go very fast. And then I'm going to go back to MySQL command line, and I'm going to select count from games, and holy crap, it's 0. What happened? How could that be? So here's my upload. There is no delete statement anywhere in here. I promise you I won't share the rest of the code, but there are no delete statements anywhere in my code. How could this happen? And just to be sure, let's go back and say like Carlson, Magnus, turn off the date filter, 0 results. All my data is gone.
SQL injection?
Yes, so what this is doing, let's look at that mystery.pgn file. It is proper PGN format. It's got all the tags. This is a real event. Got a bunch of games in here. Let's look at the very last game. So, what's anything weird here? Look at that's the event name that was read out of the text file. So let me show you. My program prints every query it runs. You shouldn't do that, but I am doing it just so we can see what's going on here. Where is it? Here. Insert ignore into events, name, site, date, values, bunch of empty strings, semicolon, delete from games. So turns out we've never actually seen this, but you can, so a semicolon terminates an SQL command, but you don't have to press enter right there. I can do like select count from games, semicolon, select count from events, semicolon, and it just runs both of them consecutively. And so that's exactly what happened there. I put in malicious information in my PGN file that inserted a semicolon and the appropriate stuff to properly terminate that first query. And then I put in a query that drops all the games. Okay.
So you just had like quotation marks and a semicolon. How does that work?
Yeah, so let's kind of just look at what's going on here. I had to know a little bit about how my chess browser was formatting its queries. So let's just look at this in a little simpler context. So now that we are procedurally generating SQL commands, like our C# program is dynamically creating something based on some input, instead of us manually typing it in. So say I have like a console.readline, get some input, and then my command is, part of it is hard-coded, select whatever where thing equals, and then I want the filter to be whatever I typed in on the command line. So I insert a quote in my C# string because the SQL command needs a quote. And then I do plus filter and then plus another quote. So if I type hi, then this is my full SQL command. Select whatever where thing equals, and it inserts those quotes to wrap around my input string. So the quote coming from the SQL, from the C# code, goes into the SQL statement because it's needed. And then my filter goes in, and then another quote. So if I type instead, if I type quote semicolon hi, then my SQL command, I am closing the quote by typing it in my input, and then I can add a semicolon. So what we end up with is a valid command, because I closed it with I closed the quote and then put a semicolon, and then the rest of that is just garbage. So you'll get one valid command and then one error. If I type close quote, semicolon, and then anything that's a valid SQL command, semicolon, then what I end up with is two valid commands. And there may be some extra garbage there on the end, but the server will actually run all of the commands in order until they're no longer valid. Okay, so let's look at another example. Since I just totally messed everything up, I'm going to clear everything out again. So I'll delete from events, delete from players, and now I'm just going to upload those original games again. Just because there's really no good way to fix what I did. I had events and players in there, but I didn't have all the games. It would be very hard to go and fix that.
Does your solution take advantage of like batching the games to be inserted, or is this pretty much just fast-paced things?
So does my solution batch the games? No. This is a particularly slow solution.
Okay.
Your solution should, especially since there'll be so many of you doing this. You don't want to overload the server. Okay, so we're hopefully, let's see if we're back to a good state. Okay, so there are the three games with Magnus Carlsen. I can also, so all of this stuff, the upload PGN generates a bunch of insert commands. The go button generates a select command. So what if I type in here, what if I type or true? So close quote or true. And I get every single game returned. 809 games, and I got all of them through SQL injection. So let's look at the command now. What's it actually turning into? So we'll go back to Visual Studio. Here's that last select command that was run. So select a whole bunch of stuff, name, site, date, blah, 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 bunch of joins and stuff. Okay. Where p1.name equals blank string or true. Or true on any condition is going to make it result in true. So, okay, maybe that's not that bad, like big deal. My filter didn't work, it gave me everything instead of something. But let's pretend now for a minute, this is not a chess browser, this is like a bank account application. And this is not white player, this is username. And this is password or something. So I type my password in, and I type this for my username, and then I click go. And this now, pretend that's bank account information. I've got the information for every single bank account just by knowing a little bit about, or assuming a little bit about, how this program might be generating SQL commands. Okay. So this is called an injection attack. And it's not just specific to SQL. Basically, anytime a query or some code is procedurally generated, then the user can insert malicious commands. So there's SQL injection, JavaScript injection, HTML injection, and they're pretty pretty big security flaws unless you specifically do something to prevent it. There's even, going way back, an older form of injection attack. So you've probably all seen, or most of you probably have seen, like buffer overflow or heard of buffer overflow attacks, where, you know, say some C program is asking for input on a keyboard, and you have the input buffer somewhere in memory, which only goes up to that line. And if your program doesn't do anything to prevent the user from typing more than that, then they can type enough information that goes and overwrites the return address. And even beyond that, they could write raw instruction bytes. So they could actually put in machine code in the string that they enter in. And you could do it in such a way that the return address jumps to those instructions that you inserted. So, you know, say there's a call to scanf or read or whatever. You type in a bunch of filler just to fill up the actual buffer. Then you type a return address. Then you type a bunch of bytes for machine instructions. That's like, you know, one of the oldest and worst forms of an injection attack. It may not be called an injection attack when you usually hear about it, but it's kind of the same idea. Okay, so what do we do about this? The problem is that my code is just blindly taking any input the user types and just appending it to the string, the command that it's using. So what we could do is kind of run a sanitization on the input before putting it into the query. And so say my input has some quotes in it or some other kind of character that's special in SQL. Then I sanitize it, and what it does is it actually puts in a backslash character into the string. And then when I pass that to SQL, SQL will see the backslash and treat the quote character literally instead of closing that part of the query. So kind of pseudocode for what that might look like. Take in a string. For every character in that input string, we just check if it's one of the special ones, like a quote, a %, a backslash itself is special. If it is, then we prepend a backslash in front of it, and then that escapes it from SQL. Okay, so my command now would be, let me copy just this part of it and just go into like a text file. So here's the bad part. Here's what I was able to inject. If I were to sanitize this string first, here's the entire part that the user typed. That's the user's input. If I were to sanitize that part, I'd put a backslash right there. So now the SQL command is all of this stuff is treated as the string we're looking for. And this is not an actual OR clause in SQL. Okay? The other and better way to do it, but not always available. So it is important to know this method. But the better way to do it, especially in a modern language, is through something called prepared statements and SQL parameters. So these are supported in SQL 4.1 and later. And basically what it does is it allows you to specify which parts of the query are static query logic and which parts of it are inputs. And then the server automatically treats those inputs as only inputs and will never change the semantics of the query. So I kind of just put like blue boxes here because it really is actually a different kind of query when executed on the server. Don't think of them as like dynamically replaced with text. It's more like they're dynamically replaced with arguments or parameters. So these things, I can say where the parameters are in my query. And then the rest of it, so all this text in red, that's the static query logic that the server will always treat as query logic. So the way this looks in in C#. It directly supports doing this because MySQL directly supports doing it. Is we kind of write our command text in a similar way, except we put in placeholders instead of like putting in a quote and then ending this string and then putting in a variable and then another quote. We just put in an @ symbol and then just some name. So I mean, it doesn't have to be val1 and val2. I just made those up. Okay? And then before we execute the query, we actually have to replace those with the real values that they will become. So after setting up the command text, then I do command.parameters.addWithValue. I specify the string, which is the placeholder I want to replace, and then just some object. So that could be a string or an int, or a date time, or anything. And then the system kind of automatically sanitizes or cleans out and only treats that as a variable that will never be able to close off a quote that came from the original command. Okay, so everything else is basically the same. You make the connection string the same way. You execute non-query. You read the result with a reader, everything like that. The only difference is this. So it's pretty minimal change, and then SQL injections are fixed.
So you said that SQL directly supports this?
Yes.
What is the SQL syntax?
What is the SQL syntax for doing this?
Yeah.
Like on the command line?
Yeah.
Yeah, it's kind of like this. It's a little, this is like specific to C#. Off the top of my head, I couldn't actually even tell you what the exact syntax is, because when you're running a command in the command line, you're usually kind of in charge of the whole thing, and you're not going to like injection attack yourself. Injection attacks they're really a problem. The reason injection attacks exist is because SQL commands are dynamically created by a program. So instead of hard coding a command that you know is safe, you hard code only part of the command, and you allow the user to gain access to parts of it, which is where they can inject the malicious parts. Okay, so let's fix our chess browser to use parameters and prepared statements so that it's not vulnerable. But let's take our 5-minute break first. Here is basically the problem. So remember, let's go look at the bad file. I was injecting my attack into the event tag. So that means right here where I'm inserting an event is where the problem comes from. And if we look at this, I basically have a completely unprotected SQL command where I'm letting them put in, I'm taking exactly what they typed and inserting it verbatim into the command. So really what we would do is something like sanitize g.event name or whatever. But instead of manually sanitizing it, we're just going to use a prepared statement. So I will comment out this part. Keep the execute non-query because that'll be the same. And I'm actually going to copy most of this because most of the command is still fine. Okay. So then the problem is where the variable part comes in. So I'm going to put this on a new line so it's easier for us to read. So insert ignore into events, the columns I want to insert into, all hard-coded. And then values, and then we'll just get rid of all of that. Okay, so instead of doing it the bad way, we're going to use prepared statements with parameters. So we're going to do something like name, site, date. Okay, so those are just placeholders that I just made up. I gave them the same names as their actual column names. And then we do command.parameters.addWithValue. The parameter name that we want to do first is @name, and then the value we want to give it is, so G is a game object inside of this for loop, one of the games. G.get event name. Okay, so that's one of them. We'll do the same thing for site and date. This is get site and get date. Okay. And then we can do command.prepare, which means I've set everything up, I've put the parameters in. This will tell the MySQL server to basically compile that command. Turns out you don't actually even need to do that, just because by executing the command, obviously it has to compile first, so it'll do it automatically. Okay, so let me reset everything. Delete from games, events, and players. And let's run this now. And I'll just upload small.pgn so we don't have to wait for it. Okay, so let's select star from games. Oh, let's just select count. I think there should be 4 of them. Yeah. And the small PGN didn't have any injection attacks in it, so this is all still just normal stuff. Now let's upload mystery.pgn, which is the one with the injection. Select count from games, and it didn't wipe it all out to 0. Let me, though, select star from events. And there is the literal event name that I put into my file. Now SQL is actually just treating that as a literal event name. And this quote is not causing any problem. This semicolon is not causing any problem because it's still enclosed in the parameter itself. So this is still kind of a problem. Like if someone tried to do an injection attack, they could insert just some nonsense event, but at least they can't delete all of my games. Yep.
So before the sanitization, would your injection attack work with just semicolon and then delete from games?
So would the injection attack work if I didn't put on that quote there? No. I closed the quote so that because I knew that, let's go back and look at the old code. I closed the quote because I knew that the string that the server or the program was generating had an opening quote. So I put in a closing quote to close that. Then I put a semicolon. Otherwise, my semicolon would just be considered part of the event name. Okay. So we've only fixed one of them. Like if I were to go and do this trick again, for true, that's a different part of the code in a different query, so it would still be vulnerable. So we'd have to go and change all of our statements to prepared statements instead of just the naive way we were doing it. Yep.
After that or true, you could just delete all the games again, right? Or
yep. So I could still do. Could I put a delete in the inside of the select? I'm sure there is a way you could formulate that. I don't know if just doing it like this.
Because the semicolon ends the select, right? Or does it
Oh, you're right. Yeah. No, good point. Yep. So this semicolon here ends the select. Now I can just do delete from games. I can delete from games, players, events, everything. Yeah. So you have to make sure all of any procedurally generated command should be a prepared command just to be safe. And so SQL injection attacks were like a huge problem and huge vulnerability until SQL 4.1 came along, and then it's basically just like problem solved in a very easy way. Just use prepared statements. Okay, so there's another advantage to prepared statements, not just for security reasons. The other thing is, so if we look at the code we're running here, there's a for loop here with potentially like thousands of iterations, thousands of games. Oh, by the way, look at this code here that I had before. This was kind of a very naive form of sanitization. I was sanitizing out just backslashes, because some of the names actually have backslashes in them, so I was just doing that just to make it work for the demo. But turns out we don't need this anymore now because I'm using a prepared statement. Okay, so let's look at this. For each game, possibly like thousands of them. And then I'm running the exact same command over and over again, where the only difference is these variables. Name and site and date will change. The actual logic of the query and the operations that the server has to do, like in terms of cross products and projection and selection, never changes. Only the filter condition changes. So we often see that a lot. You're going to run the same command just with slight differences over and over again. And so we can do that with a prepared statement. We don't have to change the command. We can just change the parameter. So command.parameters at that value equals some new value, then execute it again. So that the way that it would kind of look, the way I've written it is I created my command inside the for loop. Really, you would create that command outside the for loop, and initially just give it some nonsense placeholders for the values, because you know you're not going to ever execute that. But then the first iteration of the loop, you'll change all of the parameters and execute it. And it turns out this is actually faster. This is a performance optimization, because the way the database management system works is it takes your query in SQL format and actually kind of compiles it. You can think of it like compiling. It'll figure out all of the basic relational operations it needs to do, and then form what's called a plan. With a prepared statement, the plan part of the query, it can prove that it doesn't change, because the only thing changing is those parameters. So it can compile it once and optimize it once, and then execute it again. And this just reduces like essentially the compilation phase. The analogy is, imagine you're running a program, a C program, and every time you call a function, that function has to be compiled. Obviously, that's not how it works. So what the server is going to do is it's going to look at the query and logic portion of the command, compile it down to some set of relational operations, optimize it, and then cache it. And then every time you execute it, it just treats these things basically like arguments to a function call, where the function has already been compiled. You can very quickly execute it again by just changing some registers.
So does C# tell SQL to prepare statements just by knowing the fact that you have an add something?
So does C# tell it to prepare the statement? Yes, basically, the C# knows that it's a prepared command, so it invokes a prepare on the server before trying to execute it. Yep. Okay. So let's think about this. Is SQL injection really a big deal? Let's go back to the chess browser. And this is one of the things I didn't increase the font on. But up here, there's username and password. And this is database username and password. So this is like my ATR credentials, meaning I have full select, insert, and delete permissions on this database anyway. So if I'm providing my database password, then if somebody knows your database password, then that's already too late. Like, let's assume that only I know my password. Why would I then go and do something like this? Close that off and then like delete from. Why would I like SQL injection attack myself?
Either your against such, or because you're a match over.
So that first one actually is a good point. I would maybe do this to try to test the security of my program, but in reality, this chess browser is kind of a bad example of the vulnerability of an injection. If I already have the database password with full permissions, then that's the problem right there. But that's not really why SQL injection is a problem. So to figure out why it's really a problem, let's go back and look at this diagram of like a system, an application that uses a database. So it could be a web server, a C# program, the command line. The web server one is the interesting one here. So let's kind of zoom in on that. And what we have is like Firefox communicates with the web server, which is just a program. And the web server communicates with the database. So when I log into, say, Canvas, I provide my Canvas credentials. I don't provide database credentials. Canvas has the database credentials, and it decides based on how I logged in which kinds of database queries to generate. So as an example, like here's the Canvas login page. When I'm typing in my UID and password, that is not a MySQL UID and password. That's a Canvas UID and password. And the web server's job is to decide, based on how I logged in, to decide what kinds of permissions I have. Like, when I log into Canvas, I can go and see your grades, all of your grades for this class, but I can't see your grades for like your AI class if you're taking that or whatever. And that's because Canvas knows who I am, and it restricts what kind of database queries I can do. So this right here, the web server having full access to the database is why injections matter. If this was not careful, and if I were able to go into my UID field and type in quote, semicolon, delete from users or something like that, that would be very bad. So a web server is eventually where we're going with all of this. So SQL injection does absolutely matter. But just to kind of give you practice with it and get familiarity with it, your chess browser will have to be injection attack proof. So good news though is it's easy. Use a prepared statement and you're injection attack proof.
I'm just curious, have you tried to injection attack Canvas?
Have I tried to injection attack Canvas? No. There's a very close to 0% chance that it would work.
Would you tell us if you had?
I would tell you if I had, yeah.
Have you tried to inject, like, attacking?
I've never tried to do anything malicious. I'm not a hacker. Not a hacker in that sense. Hacker actually means programmer. So I'm not a cracker, like a code cracker.
Can this probably be used for prepared statements because the entire thing is like Ruby on Rails, and Ruby on Rails has a pretty nice active records.
Okay, so a tool says Canvas is implemented with Ruby on Rails, which probably almost forces you to use like prepared statements. Yeah. So like it's pretty easy to prevent is the good news. There are a lot of other security issues that are less easy to prevent. And we'll talk more about security. Security will be kind of a theme throughout this class. We'll touch on various aspects as we go on. Specifically, passwords. So actually, let's look at this diagram here. Now's a good time to bring it up. I type in my UID and my password. Canvas is saving that stuff in a database somewhere. So it has to know whether my UID matches up with my password in order to let me in. So that database is in some way or somehow saving enough information to be able to tell whether I have successfully logged in, which means it knows something about my password, which means if the wrong person were to gain access to that database, there's a table in there somewhere called users or passwords, and they could do select star from passwords and get a whole bunch of information. Turns out the way that you store a password, it just for that possible eventuality, if somebody happened to gain access to the database, you don't actually store the password in plain text. You store it encrypted. So even if they steal it, they have to do a lot more work to get anything out of it. But they still can potentially decrypt it. OK, so bottom line here is Canvas doesn't create a database account for all of the Canvas users. It creates its own notion of a Canvas account, and then it decides based on its idea, its model of you as a user, like which parts of the database to give you access to. And our LMS will work exactly the same way. So we have professors, students, and administrators. If you're logged in as a student, you do not have the ability to assign someone a grade. And that's because your web server will decide that. OK. Well, so we got through that faster than I thought I would. So we'll just end early today. And homework 5 will be out soon, before the weekend.